All right, so these are going to be super important because these are your extended response type questions. And the extended response questions are, as always, worth more than the multiple choice. We did some of these in class today, so I'm going to do number 2 with you to start with. It says the length of a rectangle is 4 centimeters more than 3 times its width. The area of the rectangle is 15 centimeters. Find the dimensions of the rectangle. So I have this rectangle, and it tells me everything is based on the width. So that means one of these sides is width. The other is 4 more than 3 times the width, 4 plus 3w. And it told me that the total area of the rectangle is 15. Hopefully you remember from geometry that the area of a rectangle is length times width, or in this case, w times 4 plus 3w. And our area is 15. So this is the equation that we're working with. I would start by distributing that w, and that's going to give me an equation that says 15 equals 4w plus 3w squared. My next step, I need a 0 on one side to be able to solve. So I'm going to subtract 15 from both sides. And I'm going to write this in a slightly different order. I'm going to write it in standard form, which is high to low exponents. So I have 3w squared plus 4w minus 15. And then from here, you have 3 options. You can complete the square, you can use the quadratic formula, or you can factor. And I'm actually going to factor because that is something that is a strength of mine, so that's what I'm going to choose. So my product when I factor is going to be negative 45, because 3 times 15 is 45, and my sum is 4. And the two numbers that'll make that are going to be positive 9 and negative 5. So I'm going to factor this into w plus 9 and w minus 5. But I have to work that 3 back in, so I'm going to try to divide them. And 9 does divide by 3. That gives me 3. But 5 does not, so that 3 is going to come up front, and I get 3w minus 5. Now, hopefully you remember that that equals 0. And hopefully you remember that when you have two factors that equal 0, you can set them equal to 0 individually and solve. So one of my factors is w plus 3, and that could be my 0. Or 3w minus 5 could be my 0. I'm going to move that up a little bit. For the w plus 3, I would subtract 3 from both sides. That would give me w as negative 3. And for the other one, I would add 5, and that would give me 3w equals 5. I would divide by 3. That gives me w equals 5 thirds. Now, you need to remember that this is a real-world situation and that we're talking about lengths. Hopefully the first thing you notice is that there is a negative there. So even though we got negative 3 as an answer, it doesn't make sense in this actual problem. So that's gone. The only thing we can work with here is the 5 thirds. And it did ask for the dimensions, which means it wants both the width and the length. Well, we know the width is 5 thirds. And we know that the length is 4 more than 3 times the width. Well, when you multiply by 3 and divide by 3, those are going to cancel. So the length is going to be 4 plus 5, which is 9. So that's our answer for that. The next section is going to talk about writing in simplest radical form. So hopefully you have somewhere your list, or you know how to create the list of perfect squares. In order to add radicals, remember that we need to have like radicals, and right now we have a radical 18. I'm going to work on number 6. We have a radical 18, we have a radical 8, and we have a radical 72. I know that the perfect square that fits into 18 is the number 9. So the 6 is still there, and 18 will break up into radical 9 and radical 2. I know that 4 fits into it, so there's a 4 already. I'm going to break that up into radical 4, radical 2. And then thirdly, I know that 72 is divisible by 36, which is another one of our perfect squares. The 3 is already there. I'm going to use radical 36 and radical 2. The thing I want you to notice is that all of these right now have a radical 2, which is a great component. So when I break these up, the square root of 9 is 3. Those will multiply. The square root of 4 is 2. Those will multiply. And the square root of 36 is 6. Again, those will multiply. 3 times 6 is 18 radical 2. 4 times 2 is 8 radical 2. And 3 times 6, again, is 18 radical 2. When we're looking at these, there was a plus sign in between the first two and a minus sign in between the last two. I hope you see that we have an 18 radical 2 and a negative 18 radical 2, which will cancel out, and that means my final answer is 8 radical 2. All right, so for number 10, we are given a polynomial, 18x to the third plus 27x squared plus x minus 4. And we know one of its factors is 3x plus 4. So we're going to start by putting that 3x plus 4 off on the side. And then the the first term, and the last term will go in the top left and bottom right, respectively. So from here on out, I am asking myself questions about multiplication. I want to know 3 times what gives me 18, and that answer is 6. And I want to know x times what will give me x to the third, and that answer is x squared. Once I know that, I can multiply the 6 times 4. That gives me 24x squared. Then on the other side, I know that 4 times negative 1 will give me the negative 4 that's here. And then I can kind of do the reverse. 3x times negative 1 will give me negative 3x. So the difficulty now becomes finding what's going to go as that middle term of the trinomial. And in this case, I have a little looking to do. So right now I have 24x squareds, but my problem says I need 27, so I'm 3 short. Because of the diagonals, that means that those 3x squareds must come in the box. I just wrote them in. Well, 3x times x is going to give me that 3x squared. And just for kicks, to make sure I have the right thing, 4 times x gives me 4x, and 4x minus 3x gives me that regular x. So I know that the answer I'm working with is now 6x squared plus x minus 1. From here, I need to factor that piece. So the product is negative 6, and the sum is 1. The things that multiply to negative 6 that add to 1 will be positive 3 and negative 2. So I'm going to write this like x plus 3, x minus 2, but I got to work that 6 back into the problem. So I'm going to do my darndest and try to divide by 6. And I'm glad that I have this problem because this is one that we're going to need to reduce on because neither of those divide evenly, but they both reduce. 3 over 6 is the same as 1/2. 2 over 6 is the same as 1/3. The 2 will come up front, as will the 3, and that leaves me with 2x plus 1, 3x minus 1, and I still have that 3x plus 4 factor that I was given. Now I'm going to set each of those equal to 0 to solve. So I have 2x plus 1 equals 0. I have 3x minus 1 equals 0. And I have 3x plus 4 equals 0. The first I would subtract 1. That gives me 2x equals negative 1. When I divide by 2, I'm going to get x equals negative 1/2. That's the first answer. For 3x minus 1, I would add 1 to both sides. That'll give me 3x equals 1. Divide by 3 gives me x equals positive 1/3. And for the given factor, I would subtract 4 from both sides. It's going to give me 3x equals negative 4. And I divide by 3, I get x equals negative 4/3. 3 answers.